Hi there, everybody. Now we're going to talk about the accessories that are associated with our integumentary system, including nails, hair, exocrine glands, such as sweat glands, which are sudoriferous glands, and sebaceous glands, which are ceremonious glands. So all of these accessory structures are known as epidermal derivatives, and we'll start with hair. So hair is found almost everywhere on the body. The areas that it's not found are in areas where we have thick skin. So areas like our hands, our palms of our hands, surface of our fingers, soles of our feet, our lips, our thick skin as well. So we don't have hair in those areas. So the hair originates from a region called the hair matrix. So there's that dermal papilla providing nutrients, and then here we have the hair matrix. This is the area where we have living hair. But as we move out, hair is just a modification of keratinocytes, and as it moves out, the cells become completely keratinized, and so by the time the hair pops out, the shaft up here pops out, you have dead cells, which is why you can cut hair without having any pain. But down here we do have living hair, so when you yank hair, it does hurt because you're pulling and hurting that living tissue down here. Hair so this is a figure from your textbook that shows that same hair follicle, but this is an actual photomicrograph of the hair follicle. So here's that matrix region, and here's that follicle moving up. Over here, interesting, you can see this. This is a sebaceous gland, so kind of cool right there. So hair has multiple functions. It functions in protection. That's probably the first thing that it does. It protects us from injury. Think of eyebrows when you're sweating, keeps the sweat from getting into your eyes. Eyelashes do the same. We have hairs in our nose. We have hairs in our ears that trap particles or dust particles or potential, insects, bacteria, whatever, and keep them from getting into the body. Hair also functions in helping us to retain heat. So hair on our head is probably the area of our body that loses the most heat. And so hair keeps us from losing heat. Individuals that have no hair definitely need to have a hat on in the wintertime to keep that heat in. Hair has a lot of receptors associated with it. So there are nerve receptors associated with all hair follicles. And this allows us to feel when something is touching our hair. So if someone just touches one individual hair on your head, you can feel it. Visual identification, to some extent, you can identify the age of an individual potentially by their hair. So newborns have a very soft, downy hair known as lanugo, while babies and toddlers have a soft, lightly pigmented hair called vellus hair. So it's the same hair that you feel on your arms typically, very soft, very light in coloration. On the top of the head, in your underarms, and the pubic region, on your face, we form typically around puberty terminal hair, which is that more hard, not as soft hair. That's the hair that we all have today on our head. And so you can identify the age looking at the type of hair that we have. Sometimes you can identify sex based on the style of hair, but that's not always true. And then, of course, if you know the type of hair an individual has, you might be able to say, no, that's my friend or whatever, because you know their hairstyle. Another thing that hair does is it helps us to send out pheromones. A pheromone is a chemical that helps in attracting the opposite sex, so it helps us in finding a mate. Pheromones are real. Typically, pheromones are talked about in the animal kingdom when you're talking about, I don't know, cats or bears or, I don't know, other large mammals trying to get a partner. Even birds probably do it. They release chemicals to attract the opposite sex. But this also occurs in humans. So we produce pheromones. We have special chemicals that are released, and there have been studies that have been done to show that we do, at different times of the month, release different types of chemicals that are more attractive or less attractive to the opposite sex. If you're interested in those studies, ask me, because that would be fun to talk about in one of our lecture periods, okay? So now let's look at our nails. So here's a nail. This is also a derivative of the epidermis. So it's a scale-like modification, that's really what a nail is, of the stratum or of the epidermis. And so it's composed of keratinized stratified squamous epithelium. The nail itself is not living except for in this root region. But the underlying tissue that the nail is sitting on and attached to is living. And so if the nail gets damaged, it doesn't always hurt. But if you damage or pull the nail up, it will hurt the underlying connective tissue. That's very painful. And so you want to protect your nails. The function of nails are to help us in grasping objects. So nails don't probably have as much of a function today as they did hundreds of years ago when we were still hunter-gatherers, so hundreds of years ago, maybe more. I guess we've been farmers for a while, so we probably weren't hunters or gatherers for, 1,000 years. But you get the idea. The idea is nails are not as important today. They are more of a status or a fashion symbol for individuals. People like to have their nails show their moods and stuff. And in talking about that, sometimes nails can actually grow improperly. So this is an ingrown toenail, and I'm sure a lot of you have seen or had an ingrown toenail. Ingrown toenails are genetic in nature, so if you have family members that get ingrown toenails a lot, it could be your genes are causing you to produce these unique growth, these unique growth problems. It also could be due to the way you cut your nails. And so here we have this really, really painful ingrown toenail moving into the skin, and what the doctor will do, a podiatrist will do, is they will numb your toe, then they will cut this entire section away. Depending on the severity, they may cut the entire toenail off, since toenails, just like fingernails, are not really important like they used to be. We have shoes that go over our feet, so our toenails don't need to protect our toes as much. I just like this cartoon. I thought it was adorable. It makes me laugh every time I see it. So I do have a video that I'm going to play for you. Again, if this does not work, all you have to do is stop the video and click on the YouTube. Just go to the PowerPoint and click on the YouTube click on this in the PowerPoint, and it'll bring you to that YouTube video, and you can watch it. And then come back to me, okay?
Hi, this is Dr. Don Palto, and we're going to be doing a total nail avulsion today. If you look at this nail, it was a little bit infected. This patient's been on antibiotics. The redness has come down on the toe. Normally there was redness here, very painful. And you see how this skin is kind of sloughing off? It's because it was very swollen, and now as the swelling comes down, that extra skin kind of sloughs off, very similar to like snake skin. And in order to do this procedure, we need to first use a little tourniquet. This is put just to protect the bleeding in the area. And we test to make sure that there's no pain in the area. And a total nail avulsion is different than a partial. Usually a partial, we take out one little edge of the toenail to relieve an ingrown toenail. But if you notice this nail, it can be lifted up and it's almost already off anyway. So for this type of a nail where it was infected and painful, it's just easier to remove the whole
what
nail.
they're doing right now is just getting the nail unattached from the underlying connective tissue layer.
You just pull or twist. And there it kind of comes off. And you see how it was kind of in the edge there, kind of like that. Now the area around the skin we want to remove as well. All this tissue, you see there's not much bleeding to the area. It's because of the tourniquet. That's kind of the bleeding will come back after. And this is all the tissue that's around the edge of it. And then you notice that in the sides of the nail, there's some buildup that we want to get out. We use a little curette for that, to get all this buildup out of the edges.
I think this is fascinating.
That's how we remove a nail. Now I'll show you how to do the dressing. This is a dressing that we do for every type of nail procedure. It's pretty much the same way. It's standard. We take a little iodine, or betadine we call it. Put a little bit of the iodine on my gauze. Take off my tourniquet. You'll see how the blood flow will return quite quickly to the area. Cover it up. And then put on a couple of pieces of tape. This is removed tomorrow. And it usually is best to take this off while soaking it in water or saline. And that will allow it not to stick, because occasionally it can stick and become a little painful.
Love it. So, I'm a big
for an ingrown toenail. It's better to go see a doctor sooner than later, especially with
I think,
if you need to be on
I just think ingrown toenails are really fascinating to me. I'm sorry. And I'm going to finish this lecture and start a new one over the glandular tissue, okay? So I will talk to you in a few minutes. Bye.